Okay, part 3, hopefully the final part. We're using fractional first principles. And we've got a huge expansion here. We have lots of algebraic terms in lots of places, and we just want to cut them all back. So, let's go through it. Remember to watch the first 2 parts. You should be fine with what I've just done, because I went through and I explained everything I did. And remember, if you watch the second part, this part of the board is where you want to keep your eye on, because that's going to help you get from a scary multi-layer fraction down to a smooth fraction. Okay, so 4x squared. Cross that off because we have negative 4x squared. Make 0 together. Now we have 4h. Can we kill him? No, we can't. We can't kill him because there's no take 4h. However, oh wait, no, sorry, that's 4hx. And with 4hx, we also have take 4hx, so yes, we can get rid of that. Looks like he wasn't spared in the end. And then we have plus x, take x, we can cancel them out. And then we have negative 8x and positive 8x, which we can get rid of. Negative 8h. Now this is the one we can spare. Sorry, I was kind of getting ahead of myself, you know. I want to spare people, but unfortunately couldn't spare 4hx. Anyway, negative 8h stays because we don't have a positive 8h for it to make 0 with. And then negative 2 and positive 2 die. So we have 2 survivors from all of that. From all the algebraic terms we have there, we only have 2 now, which is a lot nicer than before, really. So we have limit as h approaches 0. Always remember that. It's very important to have at the beginning of the equation so we know what we're doing. Negative 8h take 8h take h over h lots of x plus h take 2 and x take 2. Alrighty, I think I need some new board space, so I'm going to leave this down the bottom and I'm going to go ahead and rub this off. So let's clear off some room. I'll keep the first principles formula up there just in case you haven't done it before. But if you need to go back in time and save all this beautiful maths, just quickly rewind and you can pause to get it all down. And I'll save this in the corner here because again that's the important rule. That's the one thing you should learn from this video series. And we have the limit as h approaches 0 for negative 8h take h over h lots of x plus h take 2, x take 2. Excellent. So what are we going to do now? Well, we have a h at the front here, and we have, in our numerator, 2 terms that both have h in them. I reckon we should isolate the h and cancel it. So let's go ahead and do that. So the limit is h approaches 0 is h lots of, and then we fill in the gaps, negative 8. And this one here, it's tempting to say it doesn't exist anymore because the h has gone out the front. But it's negative 1, because remember, there's a silent 1 there, an imaginary 1. Well, it's not imaginary, it is there, but we just can't see it. So we've got to remember to include it. And that's all over h lots of x plus h take 2, lots of x take 2. And then we can cancel out the h, so it's all good. And then we get the limit as h approaches 0 of negative 9 all over x plus h take 2, lots of x take 2. So we've gone from so many terms to that, just in a snap, through cancelling. Now what we're going to do is we're going to simplify this bottom bit, and we're making h go to 0, so what we can do here is, because we can actually make that go to 0, not like we can here, because that would be 0 in the denominator, and of course we break the universe because you can't divide by 0. But now that we just have it as plus h, we can get rid of that. So that plus h, in fact I'll keep it there and cross it out just to remind you that, yeah, that's how we get rid of that h. So now, if I just pick up my eraser, we're going to go ahead and we're going to see something similar. If you watch the first video, you may remember this. We have negative 9 over x take 2 squared. Now you're probably thinking, what was the point of this whole exercise when in the first video you just used the quotient rule and you got that within just a couple of lines, and you didn't make any silly algebraic mistakes. Well, I didn't when I went through this, but that's because I skipped ahead. But what's the point, you're probably wondering? Well, the thing is, the quotient rule is a relationship that we actually found, or, well, not me personally, but people who did calculus found when they actually use first principles. It's a shortcut, really. But we need to know how to do the longhand thing, because in your exams and in your tests, you're probably going to get something that says, using first principles, solve this. And you can't use the quotient rule there. Even though it's correct, you're not showing it using the wrong method. So you've got to pretend for a little while that this is before those people developed the shortcuts, and it's when first principles was just found and they didn't see any of the relationships yet, if that were ever to have happened. But again, let's just finish this off, shall we? So we have the limit as h approaches 0, and we use the distributive law, and I'll do it up here for those who don't know what I'm doing too much. We have x squared, because we're just using FOIL, it's perfect square law, and then negative 2x plus 4. So again, up, and yep. And that becomes x squared take 4x plus 4. So we get negative 9 over x squared take 4x plus 4. And to remember, our expected answer is negative 1. However, if you've seen the first video, you'll already know what's going to happen. So we have negative 9, and we substitute in 5 there, substitute in 5 there, and what we get is we get negative 9 all over, and that's going to be, I'll just erase that there, so it's 5, so it was x squared, so that's going to be 25, because 5 squared is 25, and that was take 4x, so that's going to be take 20, because 4 times 5 is 20, and then we're going to add 4 on the end. And that gives us 5, plus 4 is 9, so negative 9 on 9. Whoop-de-doo-dah, we're back to negative 1, because negative 9 divided by 9, any negative divided by a positive version of itself is always going to be the negative version of itself. And there we have it. Using first principles with fractions, using this to be able to work out what the tangent is at a given point, the slope of the tangent at x equals 5 for this equation. So I hope you've been able to follow that. There is a lot of algebra in there. Make sure you don't make silly mistakes. Double check your work, and always use the quotient rule to check, because the quotient rule is what will help you avoid making those silly mistakes. So thank you very much, and I'll see you in the next series of videos. We're finally done.